Hello, in this video we'll learn about construction productivity and explaining how construction productivity is represented as rate or labor units, and also be able to explain the impact of different factors on labor productivity. So productivity here is the relationship between output and input of a construction process, or a resource working with an input and providing an output at the end. So input and output productivity is the ratio between output over input. Now, output over input, typically output is the work that's being delivered and done by this resource, and input is the time that was put and required to finish this work. So let's say here that you have this hydraulic excavator. It finished 154 cubic yards in half an hour. So you make the ratio, and the rate here is 308 cubic yards per hour. Very simple concept. One thing that might confuse some people is the relation between productivity and labor units. So labor units is kind of the other side of the coin. So labor units is the ratio between input over output. So it's kind of your productivity. You want to think about how fast you can produce per hour, while labor units is how much demanding each unit in terms of labor hours needed to finish this unit. So because they are two sides of the same coin, we can still use both of them to consider or evaluate the performance of operations. So an efficient operation will have high productivity or low labor units. So what we use productivity for? Many things. The famous one is calculating the duration of the activity of this operation. So the duration is equal to the quantity of the work, total quantity of the work of this activity, divided by the ideal productivity, which we'll see how to analyze it and calculate it in a later video. This ideal productivity is multiplied by efficiency. And efficiency factor here is something between 0 and 1, or 0 to 100%, to account for many things that ideal productivity did not account for. Ideal productivity accounts for availability of resources, their dependency on each other, but there's breakout incidents, there is break or rest times, there's a lot of things can happen that can deviate you from the ideal productivity that you calculate on a spreadsheet, on a piece of paper. So you're dividing the quantity over the effective productivity. So this is just an example here, a painting job where you have the quantity here has the same units of the productivity of the work. So square foot, 5,000, and productivity is also measured in square foot per a unit of time, which is here in this case is day. Productivity can be a daily productivity, can be an hourly productivity. Depending on that, you will calculate the duration in the respective units. So if we're using here a daily rate of productivity, then you will end up with a duration in days. So moving on to what factors affect productivity. So many factors, like even psychology, enthusiasm of the labor, their comfort and feeling comfortable in their work, but we'll not cover that. We'll cover the technical factors here. So 4 factors. The first one here is space congestion. So we always say, like, if you want to finish fast, just add resources, add labor in the activity, and they will keep doubling the production rate of your crew. But this is true up to a point where, if you look at this graph here, number of laborers in a workspace, imagine this painting job that we just covered in the last slide. If I keep adding painters in this room that's being painted, at some point it will reach a peak and then go down, because now all these laborers in the same space are impacting each other, hitting each other, tripping on their toes and all of that. So there are different studies kind of examine this bad impact of congestion on productivity. But this is an example study here that found that ideal productivity of a sample of construction tasks were found to be 200. Were found to be done at a space that's not less than 205 square foot per person. If you drop below this value, your productivity will decrease, and they found, for example, that if you drop to 112 square foot per person, your productivity will suffer 50% loss. So space congestion on site is a big factor, and kind of trade stacking, this is kind of another term used in the industry. Stacking trades on each other will have a negative impact. So electricians working, they do not like to be stacked and work in the same space with other trade crews. So it's a very critical factor here to consider. Learning curve is something that we understand and we know it exists, but it's hard a little to quantify its impact on productivity. But I'm sure you learn or you heard about the learning curve before, but the idea is, look at this conceptual graph. The more units you do, the less labor unit hours or labor units needed here. So it's kind of the less time you need for each unit you do. So because the more you do, the more custom you do to the process, and the faster you do each one of the units you do. But the point here, if there is any disruption happening, so if you work, and one day, oops, there's something happening, I can't work, I have to wait a day or two. When you come after a day or two, the time you put for each unit is not the same that you had before. So you interrupted your learning curve here, and you start at a higher input for each unit, number of hours or the time you put in. So learning curve is something also that contractors know it exists, but it's a little hard to quantify. Weather, on the other side, is very critical, and there are studies, a lot of studies kind of looked at it. So this graph here is kind of collection of studies. It tracked the impact of temperature and humidity on 3 different tasks here. So these curves here are for electrical work, mainly installing outlets. And then these curves here are for bricklayers, and these curves here are for equipment tasks. So operators working in equipment, an excavator, let's say, and the operator is inside and working in there. If you look here, the human comfort zone is kind of between 50 to 70 degrees. So these are Fahrenheit. So the Fahrenheit is the lower scale here. You can see here between 50 and 70, kind of this is the plateau or the best production, which is 100% of the ideal productivity would have. So it's kind of, this is the best. And so, but there are differences between trades, if you can see. So bricklayers, they work outside, so they are very kind of impacted by weather. So any change in weather will dramatically impact their productivity. But electricians work inside, and also they do light work. Bricklayers carry blocks, put it, and carry all heavy stuff. So the impact of temperature on them is much more, they're more sensitive to temperature, you can put it this way, than electricians. But also in smaller or lower temperature or cold weather, electricians can still work because they are working inside, right? So inside you can have heaters, you can still keep them going, working inside. Equipment, kind of the same side, the same thing almost. The operator is working in a cabin, it can be heated, and they're protected from the weather in some way. So bricklayer is an example of a trade that's very sensitive to weather. Another thing to look at is the humidity. So You can see here the top curve here is humidity of 0.6. The lower curves are kind of the high humidity and low humidity. So you don't want to have very humid, wet weather and also very dry weather. Both of them are bad for productivity. So the best humidity here is 0.6, 0.5. So weather is very critical, and it's actually one of the factors that pop up a lot in construction claims and disputes. So when it rains, it's big disruption in construction sites. The next factor we consider here is overtime. Overtime, so the regular schedule is 40, it's expected to be 40 hours per week. When you have overtime, then exceeding that, there are different kind of standard overtime policies, 50 hours per week or 60 hours per week. This graph here is showing how far or how long you implement this overtime policy, how many weeks, and then the impact on productivity here. Again, most of these productivity impact studies, they related to the ideal productivity. So 100% ideal productivity and 50% ideal productivity. You can see here the first week of implementing overtime, there is big shock and workers kind of adjust to the overtime schedule, and then kind of they get used to it, so they pick up some productivity that they lost in the first week, but over time they experience fatigue. And you can see here the lower curve, of course, is the 60 hour per week, while the top one is 50 hours per week. Makes sense? These ones work 10 more hours per week. So when you implement overtime because you're behind schedule, you have to be aware that it has negative impacts on productivity. So yes, you have more hours to work, but your rate is less. So you take more hours to finish the same unit that you could have finished in less hours using the regular 40 hours per week schedule. The last thing we're going to cover here is how now these factors are considered in the construction industry. General contractors don't deal much with that, but subcontractors and specialty contractors very much deal with that. So every trade and every every subcontractor will have their own kind of, within their discipline, their professional associations kind of publish guidelines of how to consider different factors and their impact on productivity, but they look at it not as a productivity, they look at it as labor units. Remember, labor units are kind of the other side of the coin of productivity. So this is published by NECA, National Electrical Contractors Association. So it's basically a bunch of electrical contractors, and they kind of have a list of what conditions, what factors affect productivity, and they score it. And then they add these scores, and they have another table that can say if you are between this range and this range, then you are in this difficult condition and you should reduce your productivity by this percentage. So different trades have different ways of considering the impact of different factors on productivity. This is kind of the full table of the NECA labor factor adjustment sheet. So we learned about what is productivity and what is labor units and what's the relation between them, and also kind of learned about the different factors that can have significant impact on labor productivity. Thank you and take care.